Welcome to the updated AgriMetSoft IDF Curve Tool. In this tutorial, we'll demonstrate the complete workflow for generating rainfall intensity duration frequency curves from raw rainfall observations. Click Open File and select the Excel workbook containing the rainfall time series. Choose the worksheet that contains the rainfall data. The first column should contain Excel-formatted date and time values, while the second column contains rainfall measurements. Select the correct sampling interval. Choosing the proper timescale is important because the software uses rolling duration aggregation to compute rainfall intensities for every supported duration. The year type option lets you define how each analysis year is constructed. By default, the tool uses the calendar year. If your study follows a hydrologic or water year, simply select a different starting month from the list. Under Maximums in Output, choose how the maximum rainfall intensities will be extracted from the record. Yearly Maximum creates the Annual Maximum series, which is the standard dataset used for most IDF frequency analyses. Maximum of a month extracts the highest rainfall intensity from a selected month in each year. Maximum of a season uses one of the predefined 3-month seasons. If you are working with a complete rainfall record, leave the progress bar option enabled, then click Load Data to begin processing. The software aggregates the rainfall data for all supported durations, computes the rolling rainfall intensities, and extracts the selected maximum values for each analysis period. When the calculation is complete, the rainfall intensity table is created automatically and displayed, ready for frequency analysis and IDF curve generation. There are 9 available return periods. Simply check or uncheck any option to include or exclude it from the analysis, and edit the value beside each checkbox to specify any return period required for your project. Next, select one of the 9 available probability distributions. Each distribution uses a different statistical approach to estimate rainfall intensities for the selected return periods. Click Plot IDF to generate the intensity duration frequency curves. By default, the vertical axis is displayed on a logarithmic scale, but you can switch it to a linear scale. You can also display the fitted IDF equation directly on the chart. Simply check Show Equation, then click Plot IDF again to redraw the chart with the selected equation. You can customize the chart by editing the title and the horizontal and vertical axis labels. When you're satisfied with the results, click Export IDF Data to save the computed IDF values to an Excel file. The GEV table compares all available probability distributions and ranks them according to how well they fit your rainfall data, helping you select the most appropriate distribution for your IDF analysis. Now I'm changing the distribution to Log-Pearson 3. Click IDF Equation to fit empirical equations to the generated IDF curves. The dialog displays one global Katsuyanni's equation that represents all selected return periods and a Sherman equation for each individual return period. Both results can be reviewed in the table and exported as a CSV file. The Specs distribution window displays the fitted distribution parameters together with important statistical properties. It also lets you visualize the cumulative distribution function, or CDF, and the probability density function, or PDF. Both the charts and the underlying data can be exported for reporting or further analysis. The QQ plot compares the empirical quantiles from your data with the theoretical quantiles of the selected probability distribution. The closer the points are to the diagonal line, the better the distribution fits your rainfall data. Thank you for watching this tutorial. If you found it helpful, please like the video, subscribe to our channel, and click the notification bell so you never miss future updates from AgriMetSoft.